Welcome to solverfy.
So here the question is, the complex ion IUPACN tries 2 plus has been used as a prop for the structure of DNA. Phen, that is PHEN, is actually a bidentate ligand. So this we have to remember while answering, that it is bidentate ligand. And what type of isomerism is found in this first part is, and the second is this complex is diamagnetic, as are all complex ions of ruthenium 2 plus. Draw the crystal field diagram for the d orbitals in the complex ion. So for giving the first answer, that is A, what type of isomerism is present in the complex? Now, if it is bidentate ligand, we are supposed to know the structure first, and then only we can write the isomerism present in it. So, ruthenium should be at the center, with +2 configuration, and it should be octahedral geometry. So, in the octahedral geometry, we have to remember that 4 bonds are in one plane and one is above the plane and other should be below the plane. So here one bidentate ligand is present, that is 1,10-phenanthroline, and this compound, this one, we can write in short form that this nitrogen is the element which is forming the coordinate bond with the central atom, metal atom, and this is bidentate ligand. So in short, we can write this is PHEN. This is one structure. Second one is this nitrogen and another molecule, that is PHEN. So this is another part, and here again this is attached to nitrogen, and both are joined together by PHEN. So these are the 3 bidentate ligands which are forming the octahedral complex. Now this complex, if it is octahedral complex, these 4 bonds should be in the same plane, and one is above the plane and other should be below the plane, and this we have to imagine, and by this we can understand one thing, that there is no kind of symmetry present in the molecule. The molecule is asymmetric molecule, and because of that what happens, its mirror image is non-superimposable mirror image. So we can write the mirror here, and after that we can again draw the mirror image of this complex, that is Ru at the center, ruthenium, and it is at +2 oxidation state. This whole should be inside the bracket, and outside the bracket it should be +2. Similarly, its mirror image, four bonds in the same plane. One is above the plane, other should be below the plane, and this nitrogen and this nitrogen are joined together. This is one molecule, and this nitrogen and this nitrogen is part of the same ligand PHEN, and this nitrogen and this nitrogen should be attached to PHEN here again. And here also the image will remain same, that is, this is square planar geometry at the center, and one bond is above the plane and other is below the plane. So by this the whole structure is octahedral, and this whole complex should be inside the bracket. And outside the bracket it should be +2. So looking at the molecule, we can say that the molecule is asymmetric molecule. Whenever the molecule is asymmetric, then only it will be optically active, and it can show optical isomers, which can rotate the plane of polarized light in opposite direction. So this is one enantiomer, that is D form, you can say, and this is the L form of another enantiomer, and both can rotate the plane of polarized light in opposite direction. And one more important thing about this enantiomer is that there is no element of symmetry in the molecule, and that is why the mirror images are non-superimposable mirror images. So this is first part of the question, that is the A1, and now come to the B part. In the B part, the question is that this whole complex is diamagnetic. Is diamagnetic complex, and draw the crystal field diagram for the d orbitals when it is diamagnetic and the complex ion central atom is at +2 oxidation state. So ruthenium is the central metal atom, and it is like iron. Its atomic number is 44, and ruthenium 2+, which is present in this complex, its electronic configuration should be ruthenium. When it is not in the form of ion, its electronic configuration is krypton, nearest noble gas, and after that we can write it is 5s2 4d6, and in this case it should be Kr, and then 5s0 4d6. Now, if the question it is given that it is diamagnetic complex, that means no unpaired electron must be present in the complex in the d orbitals. So, splitting of the d orbital is such an electronic configuration we have to make so that there should not be any unpaired electron in it. 6 electrons we have to adjust here. Splitting of the d orbital is here, and the lower d orbital, lower energy orbitals are dxy, dyz, and dxz, and upper d orbitals are d x square minus y square and dz square. And the electrons you can feel by green. So we can write 1, 2, 3, 4, 5, 6. So this is the only possibility of the electronic configuration which can very well explain how the complex is dimagnetic. That means no unpaired electrons are present in the complex, in the molecule, and this is only possible if the d orbital electronic configuration is like this.